Welcome to VLAN. This is session number 4 on security issues in wireless and next generation networks. The topics we are going to cover in this session are introduction, security issues in wireless, robustness, wireless vulnerability and incidents, next generation networks, then packet-based networks, human-aided networks, privacy-driven networks, mobile networks or cellular networks. Wireless networking technology is quickly changing the way networked computers communicate. The convenience offered by the ability to connect to networks using mobile computing devices has also introduced many security issues that do not exist in the wide world. The security measures we have relied on in the past to secure our networks are now obsolete with this new technology. Security issues in wireless. The 802.11b standard includes a provision for encryption called wired equivalency privacy. 802.11b standards जो हैं, these includes a provision for encryption called wired equivalent privacy. Depending on the manufacturer and the model of the NIC card and access point, there are two levels of WEP commonly available. One based on a 40-bit encryption key and 24-bit initialization vector. 4. Also called 64-bit encryption and generally considered insecure, and 104-bit key plus the 24-bit for so-called 128-bit encryption. Next is robustness. Negative testing of communication protocol is called robustness testing or phishing. The robustness testing is based on the systematic creation of a very low number of protocol messages, from thousands to several million test cases containing exceptional elements simulating malicious attacks. The method provides a low-cost preemptive way of assessing software robustness. Robustness indicates the extent to which software can tolerate exceptional input and output, stressful environment conditions. So जो robustness है, it indicates the extent to which software can tolerate exceptional input and stressful environment conditions. A piece of software that is not robust fails when facing such circumstances. A malicious intruder can easily take advantage of the robustness shortcomings and compromise the system running the piece of software. As if there is a shortcoming or there is a loophole of the robustness, then a malicious intruder can definitely compromise the system running a small piece of code. The large portion of information security vulnerabilities reported to the public is caused by robustness weaknesses. All robustness problems can be exploited by causing denial of service conditions by feeding the vulnerable component with maliciously formatted input. There are no false positives in robustness testing. A found failure is always a critical failure, such as a crash or memory leak. Some of the mistakes are exploitation. An attacker can execute malicious code on the target system. If there is any failure, then definitely an attacker can execute the malicious code on the target system. So an example is a buffer overflow type of robustness flaw that can almost always be exploited to run externally supplied code in the vulnerable component. So इसका जो example है, that is buffer overflow. Wireless vulnerabilities and incidents. Wireless technology sometimes allows threats, attacks, and vulnerabilities to enter the wireless space. Malicious people will exploit any known weaknesses through service attacks, worms, spam, malware, and man-in-the-middle attacks. So the malicious people will exploit any weakness. If there is any weakness, then they can exploit that weakness through the service attacks, or we can say spams or malwares or worms, or through the man-in-the-middle attacks. Wireless networks have three additional aspects that make the security of wireless networks even more challenging than the security of fixed networks has. So we can say wireless networks have three additional aspects that make the security of wireless networks even more challenging than the security of fixed networks. These are: wireless networks are always open, because it's a wireless network, so these are always open networks. Attackers can connect into the network from anywhere and from any distance. Because it's a wireless network, so the attacker can attack from anywhere. Attackers are always anonymous. To hide their identity, they definitely attack through an anonymous user. Next generation networks. It can able to transport all type of data such as voice communications, data transfer, and also deals with different types of video technologies. Like, as next generation network is the fusion technology, so it can provide high speed communications services related to networking. Because it's a fusion technology, so we can say it can provide high-speed communication services. This technology provides the generalized mobility to the old system and advance its working properties. As a number of protocols are involved in the working of the next generation networks, so it can also provide interoperability where required. Because a number of protocols which are required, these protocols are involved in the working of the next generation networks, so it can also provide interoperability wherever it is required. It can provide different types of security features for the users to avoid the access of the restricted networking areas and prevent the whole networking system from unauthorized access. Because it can provide different types of security features for the users so that they can avoid the access of the restricted networking areas, and even they can prevent whole networking system from the unauthorized users or access. Next generation networks are arranged in a very different manner as compared to other networking technologies. Like, the particular architecture of the next generation networks based on the telephony in different steps, such as different types of networking protocols are used to separate the different components of telephony, and all are treated then separately. Components of next generation networks. There are different components on which the working of the technology based. So the most important component on which it is based is the internet. Some of the important components of internet which next generation networks are based are internet protocols, session initiation protocols, multi-protocols. Components of next generation networks. Other than the internet components, it has also some other components such as soft switch. It is that type of component that is required to control or transport the voice calls related to the IP also called as voice over IP or VoIP. It is programmable and can operate easily. Because it's programmable, so that it can be easily operate. Another important component of the next generation networks is gatekeeper. So the another important component of next generation network is gatekeeper. It is that type of device that is used to convert the analog or the digital signal into the data packets for transmission. It can also manage e-working of all the gateways take part in the working. So we can say it can also manage e-working of all gateways. Packet-based networks, a software-controlled means of directing digitally encoded information in a communication network from a source to a destination, in which information messages may be divided into smaller entities called packets. Switching and transmission are two basic functions that affect communication on demand from one point to another in the communication network. So we can say switching and transmission are the two basic functions that affect communication from one point to another in communication network, and interconnection of nodes by transmission facilities. Each node functions as a switch in addition to having potentially other nodal functions such as storage or processing. Switched or demand communications can be classified under two main categories. So we can categorize switched communication into two categories. These are circuit switched communication and store and forward communication. Store and forward communication in turn has two principal categories. These are message switched communication, or we can say message switching, and packet switched communication or packet switching. Next comes cable. Television or TV networks deliver TV broadcasts from TV stations to cable TV subscriber homes. Digital TV broadcasts using VHF and UHF frequencies between 47 MHz to 862 MHz. Each TV channel occupies 6 MHz bandwidth and modulated using 64 by 128 then 256 QAM before combines together with all other channels at the cable TV head end. Coaxial cables are used to deliver the TV RF signals, or we can say television radio frequency signals, to the subscriber homes. In order for the cable TV network to deliver high-speed data services, a set of cable network communication interface and operation support standards called DOCSIS or Data over Cable Service Interface Standards are developed by the cable industry. So, in order for the cable TV network to deliver high-speed data services, a set of cable network communication interface and operation support standards called Data over Cable Service Interface Standards, which are being developed by the cable industry. Satellite. Internet access is internet access provided through satellites. The service can be provided to users worldwide through low Earth orbit, or we can say LEO satellites. So the service which can be provided to users through the worldwide is satellite. Geostationary satellites can offer higher data speeds, but their signals cannot reach some polar regions of the world. The geostationary satellites can offer high data speeds, but their signals can't reach some polar regions of the world. Different types of satellite systems have a wide range of different features and technical limitations which can greatly affect their usefulness and performance in specific applications. So different types of satellite systems have a wide range of different features and technical limitations which can be greatly affect their usefulness and performance. Satellite internet customers range from individual home users with one PC to large remote business sites with several hundred PCs. Next is data, voice and video. Packet switching has always excelled at handling messages of different lengths as well as different priorities, providing quality of service attributes were included. So packet switching has always excelled at handling messages of different length. However, packet switching was designed for data. Yet packet switching was designed for data, but today using the IP protocol, packet networks are becoming the norm of voice and video as well. Still, by using the IP protocol, packet networks are becoming the norm for voice and video. X.25 frame relay and ATM. The first international standard for wide area packet switching networks was X.25, which was defined when all circuits were analog and very susceptible to noise. So the first international standard for wide area packet switching networks was X.25. Subsequent technologies such as frame relay were designed for today's almost error-free digital lines. ATM uses a cell switching technology that provides the bandwidth sharing efficiency of packet switching with the guaranteed bandwidth of circuit switching. So the ATM uses a cell switching technology which provides the bandwidth sharing efficiency of packet switching. Human-aided networks. Human-aided computing, an approach that uses an electroencephalographic device to measure the presence and outcomes of implicit cognitive processing that users perform automatically and may not even be aware of. So जो human aided computing system है, it is an approach that uses an electroencephalograph or we can say EEG device so that it can measure the presence and outcomes of implicit cognitive processing, the processing that users perform automatically and may not even be aware of. We describe a classification system and present results from two experiments as proof of concept. Results from the first experiment showed that our system could classify whether a user was looking at an image of a face or not, even when the user was not explicitly trying to make this determination. So the results from the second experiment extended this to animals and inanimate object categories as well, suggesting generality beyond face recognition. We later improved classification accuracies if we show images multiple times, potentially to multiple people, attaining well above 90% classification accuracies with even just 10 presentations. Privacy-driven networks. Security of information has always preceded privacy of the human throughout the ages. even in ancient times when encryption was used by Julius Caesar. As information became easier to access in the digital era, the urgent need was to protect the information secrecy or at least control access to the information. The points along the information communication channel were commonly non-human, while humans only existed at the endpoints. Privacy-driven networks continue. Thus, the only important entity to protect along a communication channel was information itself that was being communicated. Yet in this paper was assert that privacy requirement is catching up with, if not bypassing, its security counterpart due to two major developments, which are increasing human involvement and ubiquity. Mobile networks or cellular networks. Mobile networks provides communication with learners beyond their traditional places of learning. It also supports face-to-face learning by reaching out to learners outside the traditional classrooms. M-learning technologies deliver education at reduced costs by leveraging the relatively cheap mobile infrastructure. M-learning technology is an aid for the people who are suffering from a lack of interactivity. Many online classes simply provide recorded instructor lectures to which distance students listen after downloading. Cell signal encoding. To distinguish signals from several different transmitters, frequency division multiple access, or we can say FDMA, and code division multiple access, or we can say CDMA, were developed. With FDMA, the transmitting and receiving frequencies used in each cell are different from the frequencies used in each neighboring cell. In the simple taxi system, the taxi driver manually turns to a frequency of a chosen cell to obtain a strong signal and to avoid interference from signals from other cells. Frequency reuse. The key characteristics of a cellular network is the ability to reuse frequencies to increase both coverage and capacity. As described above, adjacent cells must utilize different frequencies. However, there is no problem with two cells sufficiently far apart operating on the same frequency. The elements that determine frequency reuse are the reuse distance and the reuse factor. Code division multiple access, or CDMA. CDMA based systems use a wider frequency band to achieve the same rate of transmission as FDMA, but this is compensated for by the ability to use a frequency reuse factor of 1, for example, using a reuse pattern of 1 by 1. In other words, adjacent base station sites use the same frequencies and the different base stations and users are separated by codes rather than frequencies. Broadcast messages and paging. Practically every cellular system has some kind of broadcast mechanism. This can be used directly for distributing information to multiple mobiles, commonly for example in mobile telephony systems. The most important use of broadcast information is to set up channels for one-to-one communication between a mobile transceiver and the base station. This is called paging. Movement from cell to cell and handover. In a primitive taxi system, when the taxi moved away from a first tower and closer to a second tower, the taxi driver manually switched from one frequency to another as needed. If a communication was interrupted due to a loss of signal, the taxi driver asked the base station operator to repeat the messages on a different frequency. Structure of 2G cellular network. A simple view of the cellular mobile radio network consists of the following: a network of radio base stations forming the base station subsystem, the core circuit switched network for handling voice calls and text, a packet switched network for handling mobile data, then the public switched telephone network to connect subscribers to the wider telephony network. Cellular handover in mobile phone networks. As the phone user moves from one cell area to another cell whilst a call is in progress, the mobile station will search for a new channel to attach to in order not to drop the call. Once a new channel is found, then the network will command the mobile unit to switch to the new channel and at the same time switch the on to the new channel. Cellular frequency choice in mobile phone networks. The effect of frequency on cell coverage means that different frequencies serve better for different uses. Low frequencies such as 450 MHz NMT serve very well for countryside coverage. GSM 900 or 900 MHz is a suitable solution for light urban coverage. GSM 1800 or 1.8 GHz starts to be limited by structural walls. UMTS at 2.1 GHz is quite similar in coverage to GSM 1800. Now, in the assignments, the questions are: what is wireless local area networking? Then second question is, what is cellular network? That's all for today's session. Happy learning, we learning.